So this formula, okay, n minus 2 times 180, n's the number of sides that are in that particular shape. So for instance, a triangle, you're like, well, I know how many degrees are in a triangle already. There's 180. But just to show how the formula works, my n would be 3, of course, because there's 3 sides in a triangle. So 3 minus 2 times 180. Well, 3 times 2 is 1. And you're like, yeah, duh, Harty, there's 180 degrees in a triangle. Good job. But for some other shapes that you may not know off the top of your head, this can come in handy. Ooh, excuse me. Thank you. So, an octagon, how many sides does that have?
8.
Okay, our classic stop sign, 8 sides. But the formula never changes. Only that n value is what's going to change on here. So 8 minus 2 is 6. And then again, we're going to multiply that by 180. So there's 1,080 degrees in an octagon. Okay, thank you. So, shapes can get bigger. Typically, once we get past 10, which is what a decagon is, you start just getting into the number in front of it. So if you had like a 25-sided shape, you'd call it a 25-gon or something like that, instead of getting all the fancy names here. But no matter what it is, we continue to use that same formula, with n being the only number that's changing. Okay. So, you know, when would I need to know that? Is the ACT going to say how many degrees are there in a decagon? No. But there may be a question similar to what we're seeing down in numbers 4 and 5. Because if I can figure out how many degrees there are in the whole shape and there's only one angle missing, I can easily take care of that by a little bit of work. So let's see here. Example 4. How many sides are we working with this time? 6. Even though some of my lines aren't finished here. Okay. So, knowing that there's 6, I'm just going to use the formula from up above to find out how many degrees there are in that figure, okay? So there's 720 degrees in the figure. Now, to be able to figure out the mystery angle, all I have to do is take 720 and subtract the sum of those other 5 angles. So I'd add those 5 up, and I believe, in doing this ahead, I believe it comes out to 651 on those 5. If somebody finds something different, let me know. And whatever that value happens to be, that happens to be the angle measure of that particular angle. Now, again, don't always look to see if something's drawn to scale. Sometimes they'll be really accurate, and other times you look at something like this and you're like, well, that looks obtuse and it's 78. 162 would almost be a straight line, and that doesn't look like. You just got to kind of take that out of your mind and just kind of keep plodding ahead with these. But that's going to work for any shape. As long as I know the number of sides, I can figure out how many degrees there are within that shape. So here I had 5 sides. So 5 minus 2 is 3 times 180 gets me 540. And then I just subtract the sum of my other 4 angles, which I believe is 409 in this case. And again, that's just found by adding the other ones up. And I find that missing angle. But it all comes down to the formula, okay, being able to figure out the polygon piece. So, to the back. Now, that other formula works for any polygon. Well, what happens if I'm supposed to find something outside of the polygon? Okay. Unlike the interior angles that change, the exterior angles of polygons always add up to 360. Whether there's 3 sides, 10 sides, 50 sides, it doesn't matter. The exterior always adds up to 360. So there will be a different angle measure for each of those depending on the number of sides. We're going to divide 360 by the number of sides, but I wanted to let you see why this actually works that way. So we're going to do a little extra in this first one so you can see this. All right, how many degrees are in the pentagon? Well, there's 1, 2, 3, 4, 5 sides. So I'd use my formula. And let's see here. 3 times 180 is 540 degrees. Okay, there's 540 degrees in the pentagon. Well, how many degrees are in one angle? Well, we're just going to divide that answer we just got by the number of sides there are. So 540 divided by 5 means that each angle over here in my pentagon is 108 degrees. Now here's one thing, here's one thing I will mention. Okay. These are called regular polygons. And when you see the word regular, that means all of those angles will be the same. That's different than the ones we were doing on the front where the angles can be all these different shapes. Regular means same side, same angle, okay? So before you would use this, you'd want to make sure, if it says regular, that's giving you that information, because otherwise I can't assume that. So we figured out how many degrees are in a hole. We figured out how many degrees are in an angle. So interior and exterior angles. If I were to extend any one of these lines and have it continue going out, this kind of starts to look like an art project. The angle that this interior and this angle out here make, or my interior and this guy makes, or this one and this guy, or any of these going around, are all going to be the same. So to figure out how many degrees are in an exterior angle, I'd have 180 minus whatever I already know, which in this case would be 108. So an exterior angle in any of these is going to be 72 degrees. And again, exterior meaning they're outside of the shape. Well, there's 5 of those, so 72 times 5 is 360, and it goes back to prove again that that's what my exterior angles will add up to each time. Okay? That's just kind of the mathematical way of proving it so you can see how it works. Now, we don't have to go through all of that every time, because now that we understand that, now that we've seen it in action and how it works, I can just kind of bump up a little bit here. And when I get to this last example, okay, we know the exterior angles add up to 360. How many sides do I have this time? 7. So now you're like, well, wait a minute. 360 divided by 7, I don't think that's going to go in even. And I think you're right. Ooh, what happens if I get a decimal? Okay, if you get a decimal, just go ahead and go to a decimal place. Okay, you only need to go to 1. If you wanted to go to more, you could. But otherwise, that's fine, because we're going to have a little bit of a rounding issue anyway. But that's basically all there is with some angles. It's not a bad topic. It's just getting used to that blasted n minus 2 times 180 type thing. So your job with this, then, is going to be that kind of mini sheet that's on the angle measures, that 5-question one where you find out some of the different things. And I will help out with one thing on that. Just in case some of you are wondering when you get to the practice, anybody out there know how many sides a hexagon has? Everybody's like 6. Okay. What about a nonagon? 9. Okay. And I think 3 is fairly obvious. Okay. But otherwise, you're going to just use the formula. And then 4 and 5 are like some of those last couple that we were up to. Okay. So we've got that off to your side here. Let me